ഹലോ 1 2 3 ഹലോ. ഇപ്പോൾ ലൈവ് പോവില്ലേ അതിൽ? ഹലോ 1 2 3 ഹലോ 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 ഹലോ. ആ, ക്യാമറ ഓണല്ലേ? ക്യാമറ ഹലോ ചെക്കിങ് 1 2 3 4 1 2 3 4 ഹലോ ഹലോ 1 2 3 1 2 3 എന്നാ ചേട്ടാ? അവിടെ നിന്നാണ് സംസാരിക്കുന്നത്. ഹലോ 1 2 3 ഇപ്പോൾ ഇരിക്കുന്നിടത്തു നിന്നാണ്. ഓക്കെ ആണ്. ശരി ആ വീഡിയോ ഒന്ന് കട്ട് ചെയ്തേ. ഇത് ഓൺ ഇതല്ലേ കിടക്കണ വീഡിയോ? ക്യാമറ ഔട്ടല്ലേ കിടക്കണേ? ഇല്ലേ? ഇതിലിട്ടിങ്ങനെ ചുമ്മാ ഇട്ടിങ്ങനെയാണ്? അല്ല, പി പി ടി ചുമ്മാ ഇട്ടിങ്ങനെ അല്ലേ?
Check. Check 1 2 3. Check. Check. Hello. Check. Check 1 2 3. Check. Check. Hello. Hello. 1 1 2 3. Check. Check. Hello. Check. 1 2 3 4. Check. Check. Hello. 1 2 3. Check. Check. Check 1 2 3.
Good morning, everyone. It's a matter of great honor and privilege to welcome you all to the INSA D.N. Wadia Medal Lecture being held at NCESS Trivandrum. This prestigious award conferred by the Indian National Science Academy celebrates the legacy of one of the founding fathers of Indian geology, Dr. D.N. Wadia, and honors individuals for their exceptional contributions to earth sciences. To invoke the blessing of the Almighty and set a tone for the ceremony, I now invite Mr. Jitesh Kumar to lead us in the invocation.
ചന്തമേറിയ പൂവിലും ശബളാഭമാം ശലഭത്തിലും സന്തതം കരതാരിയെന്നൊരു ചിത്രചാതുരി കാട്ടിയും ഹന്തചാരു കടാക്ഷമാലകൾ അർക്കരശ്മിയിൽ നീട്ടിയും ചിന്തയാം മണിമന്ദിരത്തിൽ വിളങ്ങുമീശനെ വാഴ്ത്തുവിൻ.
Thank you, Jitesh, for the soulful prayer. May I now request our esteemed guests to kindly come forward and take their seats on the dais. Our chief guest, Professor D.M. Banerjee, INSA Emeritus Scientist, Director NCESS, Professor N.V. Chalapati Rao, and Professor K. George Thomas, Dean ISA Trivandrum, and Convener INSA Local Chapter. So please come on the dais and take your chairs. I also request Shenu and Shamiksha to present bouquet as a gesture of our warm welcome and appreciation to our chief guest and Professor Thomas. To formally welcome the gathering and set the context for today's celebration, I now invite Professor Thomas to deliver the welcome address.
The distinguished speaker and the guest of the day, Professor D.N. Banerjee, the chair of the meeting, Professor Chalapati Rao, my good friend and the director of Srijitra Tirunal Institute of Biomedical Sciences, Professor Sanjay Bihari, friends from various organizations, NIST, friends from ISERS and other institutes, and also the scientists from this institute. Good morning and welcome to this meeting. It's my job to invite and welcome all of these distinguished guests today on behalf of INSA local chapter. There are few people attending this meeting online. I invite them also and also welcome them to this meeting first. This meeting is to recognize and honor the eminent Indian scientists who have made outstanding contributions to science and technology. The Indian National Science and Academy is organizing such meetings across the country and honoring them with prestigious medals which they have constituted. Usually these award lectures are in various geographical locations of India depending upon the area of their expertise. And this is one reason the Indian National Science Academy in New Delhi has selected this institute, because this institute focuses on geology and related research, and earth sciences, basically earth sciences research. Today we are here to remember the seminal contribution of a great Indian scientist, Darashaw Nosherwan Wadia, commonly known as D.N. Wadia, a pioneering Indian geologist whose contributions should be appreciated by the next generation, and also to appreciate the contribution of a next generation great geologist, Professor D.M. Banerjee. Let me introduce the contribution of D.M. Wadia, which may not be known to many people sitting here. To those who have sent the invitation, I have downloaded 2 articles, one by Royal Society about D.M. Wadia and also one by the Geological Survey of India about D.M. Wadia. Professor D.M. Wadia is best remembered for his path-breaking and seminal work on stratigraphy of Himalayas. His entire life is devoted to understanding the geological framework of Indian subcontinent, particularly the Himalayan region. One of the Wadia's most significant achievement was to the extensive geographical and geological mapping of Himalayas. His work provided crucial insight into the structure and tectonic evolution of this region, which remains fundamental even today. In 1919, Wadia published a book, one of the first book about geology in India. It is known as Geology of India, a seminal book that is the standard reference still today for students and professionals. This book is praised across the world for its clarity, scientific accuracy, and comprehensive coverage of India's geological features. This book is still continuing as a reference book for many geologists of the country and the world. His research on Himalayan region helped us to define the geographical timeline of various rock formation. Wadia studies tectonic movements contributing to our understanding how Himalayas were formed through collision and uplift process. During his tenure at Geological Survey of India, Wadia played a crucial role in the geological exploration on mineral resources, earthquakes studies, and hydrogeology. His meticulous survey helped to identify valuable mineral deposits in India, and he is known as the father of Indian geology. Wadia's interest extended beyond the geological mapping of India. He's contributed significantly to our understanding of earthquake patterns, and across the Indian subcontinent, even he extended to Ceylon. His research guided mineral exploration, supporting India's industrial and economic growth, and let me tell today, his initial contributions in the geology is playing an important role in our economical growth, particularly mining. He was selected as the director of Indian Bureau of Mines. You can understand the relevance of that one. He played an important role in advancing the geological research in India. He started guiding Indian students for geological research, notably through the involvement of an institute which is earlier known as Institute of Himalayan Geology, and it is later named as Wadia Institute of Himalayan Geology in 1976 in his honor. He played an important role in establishing Indian National Science Academy in New Delhi, which is organizing this particular meeting, and his contributions are seminal, and across the world it is appreciated, and on behalf of this one, Royal Society has awarded him the Fellow of the Royal Society in 1957. In very early days, he was awarded the Fellow of the Royal Society. So let me, with this background, invite Professor Chelapati Rao to introduce the chief guest and give the presidential talk. Professor Chelapati Rao.
welcome to all of you. Respected Professor D.M. Banerjee, the chief guest of today's function, Professor George Thomas, the convener of INSA local chapter, Professor Sanjay Bihari, INSA fellow, who is here, Mrs. Thomas, all my colleagues, and all INSA fellows and guests. With this, I go ahead, my pleasant duty to introduce Professor Dhiraj Mohan Banerjee. And before that, I should thank INSA and Professor Banerjee as well for choosing ESSO-NCESS as a center to deliver this prestigious lecture. Dhiraj Mohan Banerjee is born on 9th August 1942 at Lucknow, Uttar Pradesh. He has 66 years of active involvement in various aspects of geoscience related activities, beginning his career at University of Lucknow, where he earned his bachelor's and master's in 1962 and PhD in 1967 under very eminent geoscientist Professor R.C. Mishra, who was also supervisor of Professor K.S. Wadia. Professor Banerjee taught at DBS College, Dehradun, and then he moved to Geological Survey of India, the mother of all earth science organizations. He worked in Western region, Jaipur Circle, as a geologist between 1967 to 1970. Then he shifted to the University of Delhi, Department of Geology, where he served as professor and as head of the department from 1970 to 2007. So he had almost 4 decades of stint at University of Delhi, where he groomed a number of students, several generations of students. Professor Banerjee's main scientific contributions, like D.N. Wadia, include Himalayan geology. He started his work on Himalayan geology. Then he worked on Precambrian sedimentology, sediment geochemistry. He is known as the phosphorite man of India. A lot of papers he published, and he also later on shifted his interest on the arsenic pollution in the Ganges Delta, which is one of the biggest calamities of the last century and even now. He published in such top journals such as Precambrian Research, Chemical Geology, Geological Society of America Bulletin, Sedimentology, Earth and Planetary Science Letters, Economic Geology, Applied Geochemistry, Water Resources, and all very top class journal throughout his career. He also was awarded a British Council Young Scientist Award, Alexander von Humboldt Postdoctoral Research Fellowship. He revisited Germany on Humboldt Fellowship at least 4 times after that, INSA JSPS Fellowship, and he was served as visiting professor at 3 European institutes in between 1980 and 2007. And he is continuing at University of Delhi as INSA Senior Scientist, and where he also earlier served as Honorary Scientist of INSA and Emeritus Scientist. He received National Mineral Award by Ministry of Mines in 2000. And Professor Banerjee served as Chairman member of so many national and international forums, research boards, foundations, and leader of several IGCP, IUGS programs of global significance. Actually, for one thing, we should all be grateful to Professor Banerjee, because he led the Indian official delegation to Brisbane of the 34th IGC, and where India made a bid and won to have the 36th IGC in India. Actually, due to COVID, it could not take place in that grandeur, but he was the man behind it along with Professor Singhvi and others. They played a very important role in bringing IGC to India in the few years ago. He led the Indian delegation to Rome again, and that delegation won the bid to host the next INQA Congress in Lucknow in 2027. So, with a large publication profile, Professor Banerjee also has authored a number of books, the most important being the book on tectonics of Indian subcontinent by Springer, which came up 2 years ago, and he also authored a book on phosphorates in India by Geological Society of India publication. A person should also be assessed at the end of the day by the type of school he or she has created, and in that aspect also Professor Banerjee scores very high. All his students are very well settled in India and abroad. They occupy very leading positions as scientists or academicians. So, in the recent interests of Professor Banerjee include geoethics. He has been a crusader of geoethics and geoheritage conservation. You all know a bill is going to be brought out in the parliament. So Professor Banerjee and others played a very important role on the conservation of geoheritage aspects. And recently he also received a Lifetime Achievement Award from the Ministry of Mines National Geoscience Award for Achievement in Excellence in 2023. Now this D.N. Wadia medal was initiated by INSA in 1977, and if you look at the names, I'm going to read out the past recipients like A.G. Jingran, J.B. Auden, W.D. West, C.S. Pichamuttu, S.N. Sen, B.P. Radhakrishna, K.S. Waldia, Supriya Roy, S.S. Mer, Ashok Mukherjee, Vinod Gaur, Ashok Sahani, Sisir Sen, Supriya Sen Gupta, Somnath Das Gupta, and he stands along with them, on par with them. So let us give a big applaud to Professor Banerjee for his seminal contributions. And with these remarks, I now invite Professor Banerjee to deliver his D.N. Wadia award lecture. Thank you.
I'm sorry, I have a problem with my leg, so I will deliver my talk by sitting. So bear with me, if you have any difficulty. Yeah. Yeah. Okay, I think the sound is okay. Can you hear me? Okay? The sound is okay. Now, before I start this talk, I will also forewarn some of us that some of the slides here, they might have seen it in my presentation in some other institution, like Bombay IIT and Hyderabad, where, because I have been working on this topic for quite some time, and the problem has not, whatever I am going to discuss today, the problem is still continuing. Therefore, I am still speaking on this topic, in spite of the fact that I have already spoken twice on this topic with slightly different mode. So I give you the development, environment, and Homo sapiens. So what does it mean? We all want development. We are all interested that we should develop and we should have the best things in the world, and so that you have become a developed nation. Developed nation means all the facilities and all the wealth that everybody developed nation. But at the same time, we are also worried about environment. We say that the environment should not be destroyed. So that means we are having double talk, that we want development, and it is what I am trying to say, that you is a talk which you are saying you are asking development, but without losing environment, which is not possible. And who is the main culprit? Is the Homo sapien. Why I am telling you Homo sapien? Because there are so many organisms in the world, on earth, they contribute much less than what the Homo sapiens do. So I will, therefore, I have taken the three pillars of thing as a modern world. Modern world you have already. So I will start this first one here. What I say, the Homo sapiens is the only biological species capable of substantially raising its energy consumption. You eat because we eat and we get energy. We can increase our energy consumption above the level of an average metabolic rate that covers the physiological energy expenditure of an active free individual, which is about 8,400 to 17,000 kilojoules per day. That means one can have a small up to only 8,000 kilojoules, and you can also have up to 17,000, and you can still more because it can go on increasing. Therefore, what we will rather call Homo sapien should be rather called Homo technicus, because it is controlled by technical. It is Homo electricus. Why we are those who are. So the man therefore plays an important geochemical agent from the beginning of the Industrial Revolution. This is my major thing. Man as a conspicuous energy consumer emerged during the latest stages of the anthropogenesis, in which biological and cultural evolution tended to overlap. When we started, however, we had Homo neanderthal. Homo neanderthal didn't have any cover or anything. They were living in forest or anything. They don't know. So therefore, they were very poor consumer of energy. They hardly make use of any energy thing. Homo sapiens, 4,004 years ago, when it stopped, they also were very poor consumers. They didn't use it much. But the discovery of fire by early man that raised the energy consumption level till we created and we started imagining like Prometheus or Bahubali that we'd have 200 kg or 500 kg size to imagine. That means you are adding energy and making the bigger and bigger. I think this is left. Oh. Now, since we have to distinguish between two modes of human metabolism, that's number one is physiological metabolism with standard metabolic rate as the absolute energetic base level, and extrasomatic, extracorporeal variant with virtually no upper limit in energy demand. That means two types of energy demand you can see. What is extrasomatic metabolism of the human race is currently the focus of environmental concern. Our environmental concern is actually affected by the extrasomatic metabolism. What is extrasomatic metabolism? It is the waste products are manifested in contemporary industrial societies in the form of emissions of various kinds like furnaces, automobiles, exhausts, and also methane discharges from the rice and paddy fields and ungulate livestock. They are all those things, they are all keep on producing and ending the thing. On the other hand, the exploitation of fossil energy, coal, oil and gas which we use it, since the Industrial Revolution has brought affluence to modern societies unprecedented in the history of mankind. Before that, it was a very primitive society. It is only after that it has. In other words, the exponential population growth on a global scale has led to a dramatic upsurge in the total number of human individuals. Scrambling for energy in the form of food, shelter, transport, and other needs expressed by increasing economic growth rate. Higher the economy. Now, in Americans need more, Indians need much less. So this is within the society. Now, this has progressively strained the capacity of the environment of absorption man's extrasomatic waste. What are the extrasomatic waste? Carbon dioxide, sulfur dioxide, nitrous oxide, methane, halocarbons, and all those things. They keep on adding. Now, this brings us to a very essential of the issue. Number one is the toxification of a physical environment can be ultimately related to a single cause, namely the exceptionally high population densities of a single biological superdominant Homo sapiens. That means everything is actually related to a number of Homo sapiens on Earth. So no other thing. This is also related to, I will explain to you now. This is also the geochemical matter, like a carbon budget. We see the carbon budget in the ocean and the land is a constant. It has remained constant throughout. There may be some variation, and whenever there is variation, and that is what we call the scientific geological perturbations. But it should remain constant. So the total amount of carbon which is there in the ocean, the total amount of the carbon which is on the land should remain constant. But if you keep on increasing man one or the other, that means you are continuously transporting the carbon and phosphorus from the sea and making more man. So therefore you are depleting ocean all the time and making the land richer with carbon and phosphorus. So you are actually keep on adding your causing disturbance. You are leading to a price when there will be crisis, and that will be another perhaps a boundary condition which will say, okay, there is a sigma, there is carbon C13 has make a shift like that. Now the principal determinants of a given biomass growth in general and the increase of biological population in particular include one, the living systems that have an intrinsic drive to proliferate until they keep on proliferating. See, human population keep on proliferating until they encounter an externally imposed limit. Something external has to be imposed, only then they will stop. And they strive to occupy all empty spaces. Empty spaces mean wherever there is a space, including the actual land space. All empty spaces, thereby straining the spatial and nutritional capacity of the environment, leading to virtual exhaustion. That means the total amount of the nutrient which is available, not only with the space that is available in the earth, is being exhausted by adding more. And every person is being added, and it is being a part, is actually consuming that, taking away, and therefore your total budget is becoming less and less. This phenomena ultimately derives from an intimate property of the protein chemistry. To aim at boundless self-expression, that is to realize itself of the expense of an inorganic world with a concomitant reckless exploitation of all available resources. That means keep on eating, you are finishing, more even. By virtue of their adaptive, we are going to adapt, we keep on adapting, because when you go to desert or you go to a swamp, the people get adapted. By virtue of their adaptive capabilities, organisms have been extremely successful in populating in a wide range of habitat, including inhospitable environments like brines and glaciers or even high up in the tundra in the polar region, there are organisms which are lying there. Now this unrestricted proliferation culminates in a steady state which is called biotic plenitude. That is fullness, things becoming fullness, where a given ecosystem has completely occupied all the available spaces and exhausted its nutrition supply. Now only such a state of absolute biotic saturation of a given habitat is capable of enforcing zero growth for a sustainable population. Now problem is here, that means any attempt to reverse the situation, now we want to reverse the situation, has to start with a targeted effort to impose limits on the boundless procreation of the excessively proliferating species, aiming at zero growth of declining growth and compatible with the carrying capacity of the environment. The capacity of environment is there, and you are actually disturbing that. Now this is a graph, which is a very small graph, which says, you see on the left side you have a number of individuals, increasing number, and it's with time. With time it is going, and this curve takes a place. According to this logistic curve, the population tend to increasing exponentially, which reflect the growth of a population within a finite ecosystem and constitute the integral of the differential equation here. The curve is valid where there are no external constraints. I mean, we are not adding any external constraint, like there may be an eruption of a volcanic, there may be a tsunami, or there may be a plate tectonic movement. We are not taking, we are considering that it's stable condition is there. So it reaches a point where it is called K. This is the formula which we shall use it. dn by dt by r and k by n by k. K is the spaces, the numerical expression for the upper ceiling. That is the maximum what you can do. That is the limit of the growth. You cannot go. So increase of population n is a population, is proportional to n to a power factor n, r, which expresses the potential average increase of this population with no external coercion. There is no control on that. Therefore, in negative feedback term, if you say KMIN, reflect the proportion of vacant spaces, or vacant spaces mean of life opportunities where we can live, we can do any work, to the total number of K available spaces in the population. The space must be available, only then it could be fitted in. Now these spaces need not be territorial. It is not that it has to be only India or Pakistan or Sri Lanka or the space available. Slow space is a rather refers to a chance of a single individual to share in the life supporting resources primarily secured by the logistic of nutrient supply. That means total nutrient supply where the space is available. Now what I just told you, this function of the curve provides a plausible model for the observation that living population tend to proliferate exponentially until they hit a ceiling, which I just showed you a K, which inhibits a further increase of community. There is a leaf ceiling which is coming there. Now the saturation level K, therefore, represents an upper limit of standing population, which is then fixed at a quasi-stationary level due to a balance between birth and death rate. So you have to take care of how many people are dying and how many people are growing. So this K depends on rate. So these universal constraints apply with appropriate specification to microbial communities as well as to the biological superdominant Homo sapiens. Factor 1, which is actually available to the microbial communities, is the availability of biologically utilizable reducing power for the reduction of carbon dioxide to carbohydrate levels in autotrophic pathway of carbon fixation, how the carbon fixation. Factor 2 is the availability of critical elements, phosphorus and nitrogen. This is what applies to us. The factor 3 is the autotoxic effect induced by the excessive release of metabolic waste in high density system. We are taking out the amount of metabolic waste. So factor 1 is irrelevant to species like ours, but factor 2 have the trophic control on the widest sense, certainly have imposed several severe limits on population growth during the history of mankind. It has been because people have died, people have some of the population has been washed off. Some of the you can say dynasties have gone. So it has kept on sort of controlling it. Factor 3 is the most important, is responsible for the accumulation of toxic waste and creating of a local environmental nuisance. So today we know we have agriculture surpluses. All over the world, the shortage of food will not be a constraint on further numerical growth. That people, because of the poverty and because of the food, because food is now enough in the world, they are growing everywhere, and therefore that is not a restriction. That is, there will not be a reduction of population because of the lack of food. Because hunger will remain linked with disruption caused by war, civil war, ethnic war, but primarily hunger will not be a major problem in this modern world. Nevertheless, the finite carrying capacity of the planet as a whole will certainly impose discrete limits on the food production. Now food production also will have to have a ceiling, it will go there. Therefore, but the human ingenuity, human people, we are it is difficult to predict the level at which such film will ultimately explode. It can go on. I mean, people may be able to find new techniques. Every day you are finding new techniques and you do modify. Therefore, human ingenuity is such that it will find some way to support itself. Now, through what I say, through intellectual endeavor and effective social organization, by counseling and making the counseling, humans have circumvented major nutritional deadlocks. Right from the prehistoric time, they have stopped. With the dramatic increase in food production, now most important material. Now everybody knows that increased utilization of fossil carbon, we have been using it, is causing grave environmental problem. In economies relying on poor quality fuels like lignite, sulfurous coal, gas, forest wood are compounding the pollution problem like that, adding more CO2, SO2, methane, arsenic, fluoride, radioactive waste, and etc. with more development. Now on the other hand, more affluent, increased energy flow has also led to more affluence and increased life expectancy. More material you have seen. The increased GDP is evidently root factors like longevity in humans, such as balanced nutrition we are getting, reduced body of toil, intensive medical care are all attributes of developed societies. They are characterized by formidable rates of energy consumption. All these things are modern things, but you are using enormous energy. To implement a large-scale medical care program, for example, Dr. Sabi can tell you, large-scale medical program, society had to allocate a significant portion of its reduced resources, and an intelligent labor force to primarily unproductive medical care. Because medical sector is a service sector, but it is unproductive because it's not actually contributing to the general, but it is a factor which controls the welfare of the people. Now, although significant impacts on average life expectancy due to improved water supply, quality, immunization programs are not only energy sensitive, they remain dependent on the scientific and economic infrastructure of a well-organized industrial society. Now, very interesting, lastly, a striking demonstration of this covariation between the energy-related GDP and life expectancy has been provided by the socio-economic development of India, where expectancy increased from 48 years in 1947 to 72 years in 2025. Now you see, same thing actually was originally expected in West Germany and East Germany. When the East German expectancy was 67, while the West German expectancy was 72. After the merger, it became demonstrating. So, the development cost more and more energy efficient. West Germany was using more and more of energy and making it more modern, therefore life expectancy increased. Now, in view of this result, of this involuntary socio-economic achievement, it can be proclaimed that the average life expectancy of an individual of the broadly of the same gene pool is supposed to vary significantly in response to socially economic environment. Now that means a substantial cutback in energy consumption will need to lower GDP and poor living condition. If you reduce lower living condition, which is the antithesis of pursuit of happiness. Happiness doesn't come when you are poor. Happiness comes when you are affluent. So if you cut back the energy, you sort of lose your and then you lose your happiness. So there is no way out of this dilemma except the heavy investment in developing clean resources, efficient use of energy, and hydrogen-based technology. So this is a realistic forecast. Therefore, it's possible results into the success of the technological fixes will be offset by the increasing demand of increasing population. Keep on increasing. Unless we are prepared to resort to the ultimate fix. What is that? Aiming at a numerical stabilization of the world population at a level compatible with the acceptable standard for the quality of human life and the varying capacity of environment. Lastly, hence, the final decisive factor is a restriction on the number of individuals on earth conforming to the carrying capacity of the earth environment. Birth control may be assigned the role of the final decisive technological fix for our environmental problem, since population growth constitutes an ever continuing onslaught on the biological impulse against the establishment of affluence in most parts of the world. Thank you. Did it make any sense? Okay. Anybody want to? Yes,
Yeah.
sir. I'm available here after till evening. You can talk to me.
Thank you, sir. Thank you, sir, for insightful and inspiring lectures. I now request our director, Professor N.V. Chalapati Rao, to kindly read the official citation and present the INSA D.N. Wadia medal to our chief guest. So, please.
Sir, this is a citation of Darashaw Nosherwan Wadia Medal 2021 to Professor Dhiraj Mohan Banerjee, Fellow of Indian National Science Academy. The citation reads, the Darashaw Nosherwan Wadia Medal of the Indian National Science Academy is being awarded once every 3 years since 1977 in recognition of outstanding contributions in the field of earth sciences, including geography. The medal for the year 2021 has been awarded to Professor Dhiraj Mohan Banerjee, FNA, former Professor and Head Department of Geology, University of Delhi, for his significant work on stratigraphy, sedimentology, trace elements and isotope geochemistry of the Cambrian and Precambrian meta sediments, phosphorites and stromatolitic dolomites. Professor Banerjee is an internationally acclaimed geologist. He began his career by mapping the stratigraphy of a virgin Precambrian terrain in the Kumon Himalayas. As an Alexander von Humboldt Fellow, he made significant contributions in the fields of geochemistry, isotope stratigraphy, and the intercontinental correlation of the Kroll Tal rocks in the Lesser Himalaya as well as the evaporites of western Rajasthan. Isotope geochemistry of the Aravalli rocks by him led to the revision of Aravalli stratigraphy, providing deep insight into the ages of Indian Proterozoic successions. His conceptualization of phosphorus iron coupling in the Precambrian rocks led to new phosphorite discoveries in Angola, Spain and Brazil. He established the link between groundwater arsenic, organic matter and paleosalts, leading to a reassessment of the geohydrological framework of the Ganga Delta plains. He contributed significantly to the revision of the Cambrian and Triassic stratigraphy in the Himalaya. A stratigraphically significant Cambrian sponge spicule, Archaeostrela dhiraji, is named after him. He now works on geoheritage, geopark and geoethics issues. Professor Banerjee has served as global co-leader and Indian convener of UNESCO IGCP projects 156 phosphorites and project 386, that is response of ocean atmosphere to past global changes. He organized 2 international IGCP field workshops in Rajasthan, Lesser and Tethyan Himalaya. He chaired ILP SCL committee and the IUGS INQA committee for several years and led the Indian delegation in presenting the bid to host the 36th International Geological Congress in 2020. He serves as the editor for biographic memoirs and subject editor for proceedings of Indian National Science Academy and also served on several INSA committees. He co-edited major Indian reports for IUGS in 2012, 2016, 2020, 2024 and co-published a new tectonic map of the Indian subcontinent. He supervised the work of 15 PhD students in India and abroad, and many of them now occupy leadership positions in academia and industry worldwide. Professor Banerjee is a recipient of National Mineral Award in 2000 and the National Geoscience Award for Lifetime Achievement 2023 by the Ministry of Mines, Government of India. Professor Dhiraj Mohan Banerjee was elected to the fellowship of the Indian National Science Academy in 2000 and served on its council as a member during 21 and 23. So that marks the end of citation. So I think I invite Professor Thomas and Professor Bihari, INSA fellows who are in this form, to come over here.
Come here.
Yeah.
You come there, go there or here?
No, we come. So please. Yeah. I think.
No, sir, you go.
No, it's fine. So let us, all of us, give it to him. This is the citation. Yeah. Okay. So this is the citation.
Now to conclude the formal proceeding, I now invite Dr. Thompson to deliver the vote of thanks.
Good afternoon, respected dignitaries, esteemed colleagues, distinguished guests, and dear friends. On behalf of the National Center for Earth Science Studies and Indian National Science Academy, New Delhi, it's my privilege to extend our heartfelt gratitude to all those who have assembled here on this august occasion. First and foremost, our sincere thanks to Professor D.M. Banerjee for delivering the D.N. Wadia Medal Lecture on the topic Development, Environment and Homo Sapiens, Three Pillars of the Modern World. A very interesting topic, sir, and your insightful presentation illuminated us, deepening our understanding and inspiring us with your innovative ideas. And your dedication to scientific excellence and clarity in sharing a complex concept is truly commendable. Sir, your remarkable scientific journey over the past 6 decades or so embodies the essence of scientific pursuit, curiosity, creativity, and the love or pursuit of knowledge. Your achievements inspire us all and remind us that there is no limit to pursuing science, and if one is truly inspired, one can go on and on. So this award is not simply a recognition of your past achievement, but it is a testament to your commitment in academics and as well as for promoting good science, great science, and mentoring very good or great scientists and students alike. So we pray that Almighty may grant you good health to continue and inspire us and ignite passion in the next generation of scientists too. So ladies and gentlemen, I request you all to put your hands together to Professor D.M. Banerjee for graciously accepting of the invitation and delivering the today's lecture. We are also profoundly grateful to the INSA Academy in New Delhi for selecting ESSO-NCESS, as our director has told, selecting ESSO-NCESS as a venue for this lecture. And we are honored by the presence of very distinguished scientists and fellows of INSA local chapter. And also we are honored to have others of the INSA members who have joined online. So your presence have truly enriched this gathering, and on behalf of ESSO-NCESS and director, thank you all for joining this program. We also extend our appreciation to all the other distinguished attendees and students who are from ESSO-NCESS and outside ESSO-NCESS as well, and those who have joined online and watching this live streaming, and whose presence has made this lecture a remarkable.
उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you all. Thank you once again for being a part of this memorable event. Wishing you all a wonderful afternoon ahead. And one announcement, lunch is arranged for our guests and it will be served in the INSA canteen. Thank you all.